All right, in section 9.2, we start studying circles. It's our first conic that we study. And in class, we've looked at how you could take two cones and put them tip to tip and create the different sections. Okay, but we're going to talk about the circle first. All right, in the circle, I've written out the general equation of a circle. If you look, there's some parts to this. There's H, and there's K, and there's R that we're going to fill in. We always have an X and a Y. Our center of our circle is always going to be HK. So they've told me that the center of my circle is 3, 0, so that means H is 3 and K is 0. And then the R is the radius. And in my problem, they've told me the radius is 3. So let's go plug the radius in first. If the radius is 3, I'm going to take the radius and I'm going to square it. So it's going to be 3 squared. Down here, let me go ahead and just put, we're going to have x minus h squared plus y minus k squared, and I need to fill in the h and the k. Well, I've labeled these already. The h is 3, and it goes here with the x, and the k is 0, and it goes here with the y. Now, we can talk about the circle as being, having the center of hk. We can also remember that h and k represent, if we're looking at a parent function, they would represent a horizontal translation of 3 and a vertical translation of nothing, when 0 is nothing. So we'll look at one in a minute that has a center of 0, 0, and what that might look like. So you just plug the numbers in. Now, if you can simplify, go ahead and simplify. The x minus 3 squared is fine, but y minus 0 is just y squared, so we'd go ahead and write it that way, even though I kind of think that this representation of it is easier for me to see, what the center is, because I can just pick off the 0 and the 3. But we want to go ahead and simplify it when we write it. And if you see one written that way and it doesn't have something subtracted from the x and the y, you can know that that one had a 0 with it, okay? You got 3 squared is 9. So this would be our equation right here. If you look at number 5, it's similar. It actually would be a parent function with a radius of 12. This is our center, and it has a radius of 12. And why I say it's the parent function is this. If I have x minus h squared plus y minus k squared is equal to r squared, and I fill that in, my h is 0 on my center and my k is 0. When I fill those in, x minus 0 squared just becomes x squared, and y minus 0 squared just becomes y squared. So if you have a center of 0, 0, you could say, well, the center is 0, 0, or you could say, well, this is just a regular circle with radius 12, and you could say it has no translations. So you can talk about it in terms of just the center and forget about the translations, or you can look at it as saying a normal circle has a center of 0, 0, and have you moved it any? All right, we haven't filled in the radius yet. The radius down here is 12 on number 5. So 12 squared would be 144. Let me put that in black, 144. There's my equation here. A couple of things people get confused about. 144 is not the radius, it is the radius squared. So you have to always square root the number over here to make sure you've got your correct radius if they give you the equation. And that's what they're going to kind of do in some problems down number 9 and so on. As I'm looking at these, I'm realizing a lot of the ones I assign have a minus sign in them, and that's okay. I'm going to pick number, let's just discuss 9 really quickly. It's x squared plus y squared is 25. Since there's nothing subtracted from the x or the y, this one has a center of 0, 0, just like I talked about on number 5 above. And it has a radius of the square, oops, it's 25, isn't it? The square root of 25, which is 5. So if I wanted to draw this, it'd be real easy to graph this one, so we'll just do this real quickly. 2, 3, 4, 5. It has a center at 0, 0, and then it has a radius at 5. So what you do to graph it is you just go out horizontally from the center, each direction, 1, 2, 3, 4, 5, be there, and then vertically each direction, 1, 2, 3, 4, 5, up, down, left, right, 1, 2, 3, 4, 5. And you just connect those as best as you can. And again, it's hard to draw a good circle, but you do the best you can. Okay, so that one would actually be considered kind of a parent function one because it had a center at 0, 0. The center was not moved any. If you look at 11, you have x minus 4 squared plus y minus 5 squared is 1. So if all you need to graph this is the center and the radius. Well, the radius is the square root of the number right here, so the square root of 1 is 1. Okay. If I label this x minus h squared plus y minus k squared is r squared, you can see there's your x, there's your minus sign, your h is 4, so you have a center at 4, and over here, here's your y, here's your minus sign, your k is 5. Remember that when you have a formula like this that has a subtraction sign in it, your coordinates for your h and k are always going to be the opposite of what they look like in the problem, because it was x minus 4, but it was 4 as the center, and y minus 5, but 5 was the center. So it's always the opposite of what it looks like. If you were just to glance at it, you might think the center was minus 4, minus 5, but it's going to be the opposite of that. Okay, to graph this is real easy also. Our center is at 4, 5, so this is translated over. It has a horizontal shift of 4 and a vertical shift of 5, so it's right 4, up 5 from 0, 0. You can look at it that way, or you could just go ahead and get this up here. You can look at it that way, or you could just say, oh, it has a center of 4, 5. However you want to think about it, there's at least two ways to think about it. So let me graph in blue. My center is 4, 5. 1, 2, 3, 4, up 1, 2, 3, 4, 5. So let's say it's here, okay? And then for the radius, you're just going to go up 1, you're going to go down 1, you're going to go right 1, and you're going to go left 1. And then you're just going to connect it and try to make a circle out of it the best you can. That's all you have to do to graph these. They're really easy to graph. Remember, on a problem like 13, since you just make a comment about it, x minus 3 squared plus y squared is 36. Since there's nothing with the y, if you wanted to write it in, you could write in y minus 0 squared to help you figure out that your center here would be 3, 0. And I'm not going to graph this one. And your radius is going to be the square root of that number 36, which is 6. Okay, and then you would just go make a dot at 3, 0 for the center, and then count up, 6 down, 6 left, 6 right from it, and you'd have it graphed. On number 15, they want you to say they're giving you an equation, and if it's a circle, find the center and radius. Okay. Some of these are going to be harder than others. This is a circle. If you think about it, if you move 16 to the other side, you'd have x squared plus y squared is 16. So they're just messing with the equation and moving terms around. And if you think about it, this would have a center of 0, 0, since we don't see anything subtracted from the x or the y. And then the radius would be the square root of 16, which is 4. Now 17 is x squared plus y squared is minus 8y. And you look at it first and you think, yeah, that's not a circle. Well, here's the deal. We sometimes have to take these equations and complete the square on them to be able to get our center and all the parts of them. Because sometimes, you move terms around and things simplify out. So let's look at this. What if I put the 8y back over here? Let me add it to both sides. That would be x squared plus y squared plus 8y is equal to 0. And you may think, well, how can you have a circle of radius 0? Well, you don't, okay? What we've got to do here is complete the square. So sometimes on equations you have to complete the square. We're going to group together. The x is all by itself. There's no more x terms. So if I want to think about x in this problem, I could think about it as x minus 0 squared. I don't really need to do anything to that. I can tell that for my center, if I'm thinking hk, my h is going to be 0. I know that already. But my y coordinate, the k that goes with the y, I got to get this figured out. So this is where we complete the square, and we use that most of all. And this is where you'll see us using complete the square more than anywhere else. You learn it, and then you don't use it till you get to conics. To complete the square, you take that b term there, and you divide it in 2. So it's 8 divided by 2, which is 4, and you square it. And you add it to both sides. Well, 4 squared is 16, so I'm just going to write it as 16 over here. So that created a perfect square. And if you remember how you do this, it's y, and this was a positive 4, so it'll be plus 4 squared equals 16. Okay, now you can see you actually do have a number there. It's just when they simplified it, it kind of all dropped out. And you don't see, you can't really tell what's going on with this until you complete the square. Now if you think about it, if this is x minus h squared plus y minus k squared is r squared, if you're trying to figure out your k coordinate, you need, if it's y minus k, remember it's the opposite of what it looks like. It may look like it's a positive 4, but it's really a negative 4. And the reason is I have to rewrite this with the subtraction sign y minus minus 4 to get it to fit this formula, right? And then my radius is just going to be the square root of 16, which is 4. So you actually can find all that on 17, even though it looks like it might not actually be a circle. All right, on number 19, you look at it and you're like, I don't know if it's a circle or not. So we'll go ahead and we'll group terms together. I see an x squared, I see a minus 4x, so I'll put them side by side. I'm going to leave a space because I'm going to have to complete the square right here. Now I'm going to put a plus y squared. If that had been a minus between the x squared and the y squared, this would not have been a circle. We'll learn what it is later. It actually would have been a hyperbola, but you don't know that yet. I'm just telling you, if it had been a minus there, it would not have been a circle. Okay, so let's group our y terms together. There's y squared and there's a plus 2y. And what we always do with the constant is we move it to the other side. So let's add 4. And we would have 4 over here on the other side now. And I'm going to group these because I've got to complete the square twice if I want to find the center. What we have up there is the general form of an equation of a circle, but we want it in this kind of, I guess you would call it vertex form, so that we could actually see what the center and the radius are. So if we're going to complete the square, let's do it on the x term first. You take the minus 4 and you divide it by 2, and then you square it, and you add it to both sides. Well, negative 4 divided by 2 is negative 2, but negative 2 squared is positive 4. So I'm going to write that as a positive 4 over here on this other side. What that did, that created the perfect square, x, and then if you remember what you do, inside the parentheses, that's what you write down. That was a negative 4 divided by 2. That's a minus 2 squared. If you don't believe that's the same thing, multiply them out and verify it for yourself that it is the same thing. Now, I'm going to complete the square on the y terms too, because I want to know, I'm trying to get it in the form x minus h squared plus y minus k squared is r squared. All right, if I complete the square on the y squared term, I take that positive 2 and divide it by 2 and square it. Well, that's 1 squared, which is 1. So let me add 1 to the other side, just so I don't have to recopy this thing so many times. I just created the perfect square there of y, and that's a positive 1 inside the parentheses, so it would be y plus 1 squared. And if you add up all those numbers there, 4 and 4 is 8, and 1 make 9. Now, I want you to see that what we've done is we've put this in the form x minus h squared plus y minus k squared is equal to r squared. One of the reasons I know it's a circle is that I have it all done here. There's a plus sign in between the two square terms. Right here is where I'm looking. Also, my radius squared has to be a positive number. If I'd come up with a negative number there, I would say that's not a circle because it didn't work out. You can't have a negative radius or anything. So if they want to know, what they want to know here is what's the center and what's the radius. Let's do the radius first since it's easiest. If I've got a 9 there, what's the square root of 9? My radius is the square root of 9, since r squared is 9. So it's going to be 3. My center is going to be the h and the k. Okay, if you look here, here's your x, here's your minus, your h is 2. Or you could say it looks like a negative 2, so it's really a positive 2. And if you look at the k term, because remember the k is with the y, it looks like a positive 1, so it's opposite of what it looks like. It will be a negative 1. Or I could have done this. I could have rewritten it as y minus minus 1, so I could say here's my y, here's my subtraction sign, and k is minus 1. So this actually was a circle, and there's its center, and there's its radius.